Hello everyone, my name is Gauri Babar and I am going to explain you ISC 2 of Computer Architecture. Topic name for ISC is Direct Memory Access, that is DMA technique in MIPS 32. So let us see some introduction about DMA. In the data transfer methods discussed under program IO, it is assumed that machine instructions are used to transfer the data between IO devices and memory, not very suitable when large block of data are required to be transferred at a high speed. An alternate approach is direct memory access. It allows the transfer of the block of data directly between IO devices and memory without continuous CPU intervention. So let us see what is DMA controller. A hardware controller called the DMA controller can enable the direct data transfer between IO device, example disk, and the memory without CPU intervention. There is no need to execute the instruction to carry out the data transfer. Maximum data transfer speed will be determined the rate with which memory read and write operation can be carried out. It is much faster than program IO. So this is the basic block diagram of the DMA. It consists of CPU, main memory, direct memory access, and IO device. These are the basic steps involved in the direct memory access. So let us first CPU will generate IO command. That command will given to the direct memory access. So the direct memory access knows now the disk will have to transfer data to the main memory. So direct memory access will wait till the disk is giving DMA request to the direct memory access. Once that request comes over here, the direct memory access will ask for the control over the system bus by hold a signal over here, and in response to that CPU will give hold acknowledgement over here. Once that acknowledgement comes, direct memory access will tell this DMA via DMA acknowledgement that now you are ready to transfer the data over here. So now disk is slower device, and that slower device will have to transfer the data to the buffer first. Once buffer is full, that data by the DMA will uploaded over the system bus. So the data will be available on the system bus. Now once data is available on the system bus, that data could read easily by the main memory. Now that data will get transferred to the main memory. This process will repeated till this counter will set to 0. So this is the basic working of the direct memory access. This transfer of the data from disk to memory is happening, but that is happening via this buffer. So how exactly that data transfer happens, that depends on the size of the buffer. And depending on the size of the buffer, it data transfer can be takes place in two modes. First is DMA cycle stealing and second is DMA block transfer. In the cycle stealing, DMA controller requests for a few cycles, 1 or 2, preambly when the CPU is not using memory. And DMA controller is set to steal the cycles from the CPU without CPU knowing it. And second is DMA block transfer. The DMA controller transfers the whole block of data without interruption, results in maximum possible data transfer rate. CPU will lie idle during this period and it cannot fetch any instruction from the memory. So these are some other applications of DMA. Other than the data transfer to and from high-speed peripheral devices, DMA can be used in some other areas as well. First is high-speed memory to memory block move, and second is refreshing the dynamic memory systems by periodically generating dummy read requests to the columns. So this is all about direct memory access. Thank you.